Good afternoon again. Today we are factoring four-term polynomials. This is also called factoring by grouping. Okay, we have factored binomials by using GCF and or also using difference of squares pattern. And we have factored trinomials that fit the perfect square trinomial pattern. We are going to use some aspects of those two types of factoring when we factor four-term polynomials. Okay, so here's our first example. Okay, there's our four-term polynomial. Now, I want to point your attention to the first three terms, because the first three terms should look familiar to you. I'll cover up the minus y squared. If you look at the first three terms, that is one of our patterns. That is our perfect square trinomial pattern. A squared plus 2ab plus b squared, where b is 6. So we know how to factor that. However, this is not a trinomial. This is a four-term polynomial. It's not just that. It's that minus y squared. So at first glance, this four-term polynomial might look daunting. It might look intimidating. But what I want you to start looking at is pieces of the four-term polynomial and seeing if pieces or portions of the polynomial do fit a pattern that we've used in the past. Okay, and these first three terms do. Okay, so let's not worry about the minus y squared for the moment and just factor the trinomial. The trinomial factors this way: a plus b squared, x plus 6 squared. And I still have that minus y squared there. Okay, now I want you to think big picture. Big picture. I have two terms here. First term, second term. I have something squared minus something squared. Something squared minus something else squared should sound like something we've done recently. A squared minus b squared, difference of squares. We know how to factor something squared minus something squared. It goes like this. Okay, so if this follows that pattern exactly, and I know how to factor that pattern, then I should be able to factor this. My a is x plus 6, so that goes first, plus my b, which is y. Okay, that finishes a plus b. Now we start a minus b. A minus b. There we go. X plus 6 plus y times x plus 6 minus y. This is our a, this is our b, this is our a, and this is our minus b. Okay, so the first step we did, we factored the perfect square trinomial. Perfect square trinomial. And then we went from here to here, we did difference of squares. So we used two patterns that we have used in the past, but now we're applying that pattern to something that looks more complicated. Okay, and now compare what we ended up with what we had. We had a four-term polynomial, and we ended up with two factors, each of which had three terms. And I also want you to remember that we looked for a pattern in part of that four-term polynomial. In this case, the first three terms made a familiar pattern. Sometimes in four-term polynomials, it will be the first three terms that make that pattern. Sometimes it'll be the second, third, and fourth term. And sometimes there will be no trinomial pattern at all. Okay, let's try that again with this one. I'm going to change letters now. N squared n squared minus m squared minus 6m plus 9. Okay, here I have something squared, then I have a minus, and then I have this entire trinomial subtracted from n squared. Okay, now it's convenient that I put parentheses around the m squared minus 6m plus 9. I had to do that. So that probably tells you that this trinomial does follow a pattern. It does. It's the a squared minus 2ab plus b squared pattern, and that factors, oops, I can't use a, I got to use m minus 3 squared. Okay, so that's my perfect square trinomial step. Now I have something squared minus something squared, again, difference of squares. N plus m minus 3 and n minus m minus 3. And I have to put m minus 3 in parentheses here because I am subtracting from n all of m minus 3. I'm not just subtracting the m, I'm subtracting m minus 3 from n. And then I am allowed to distribute that negative sign. Changing the sign of everything inside to that. Okay, so just like the first example, here there's a pattern of 3, and then a term that's by itself. So a 3 and a 1, 3 and 1, 3 and 1. Okay, third example. No exponents this time. Okay, now since we don't have any exponents, that means we don't have any perfect squares. No perfect squares. If there are no perfect squares anywhere, then that means we're not going to get a perfect square trinomial. Perfect square trinomials always have perfect squares in the first and third term. Okay, if I don't have perfect square trinomial, maybe I have a difference of squares somewhere. But wait, no, I can't have difference of squares either because difference of squares also has exponents of 2, and I don't have that. Okay, so this one must be a different animal. I got to treat it differently. So I go back to my simplest kind of factoring, GCF. Do I see a GCF of all 4 terms? Something that all 4 terms have in common. There is nothing that all 4 terms have in common. Okay. Is there something that 3 out of the 4 terms have in common? I don't see anything. Okay, then I take it down to 2. Is there something that 2 out of the 4 terms have in common? And now I see something. I see that 3xy and negative 15xz, they have something in common. And I also see that the second and the fourth term, they have something in common. So I'm going to rearrange my terms so that the terms that have something in common are next to each other. And then I'm going to take out a GCF from here, followed by a GCF from here. The GCF here is 3x. 3x. The leftover is y minus 5z. Okay, now the GCF here is I think it's 4w negative 4w, or is it positive? Positive 4w, and the leftover is negative 5z plus y. Okay, now this should look familiar. Remember when we did big GCF? A GCF that was a binomial. There's a big GCF here. Y minus 5z is the same thing as negative 5z plus y. That's my big GCF. So I take it out. And my leftover is 3x plus 4w. Okay, so let's go over that. We didn't see a perfect square trinomial. We didn't see a GCF that all four terms had, or a GCF that three out of the four terms had. So we got a GCF out of two terms. These two terms had a GCF, and these two terms had a GCF. So I rearranged the order, took out the GCFs from these two and from these two, and I came up with a leftover that was identical. So that's my big GCF. Here it is, big GCF, leftover. Okay, let's try another one like that. Okay, there is no perfect square trinomial here. There is not a GCF of all four terms. There is a GCF of three out of the four terms. I'm talking about the first, second, and third term. They all have an x. However, if I take the x out of those three terms, I'm going to get this. I get this. And I call this a dead end because, sure, I've taken out the GCF, but look at my leftover. My leftover is very weird looking. It's nothing like we've seen before. Plus, I have this minus 2y tacked on at the end. This is not going to go anywhere. It's not a factored form of anything, and there's nothing here that I can work on further. So taking out that GCF of x from the first three terms doesn't help. So then I try maybe taking a GCF out of two out of the four terms, like I did up here. Okay, when things don't work, just shrink your ambitions and look at fewer terms. So I'm going to look at the first two terms. There's a GCF of x. Actually, there's a GCF of 3x. So I take out 3x, leaving x minus y. And then I look at these two terms. I see a GCF of 2. Leaving x minus y again. Okay, this is good news because I have a big GCF. So I take that out, x minus y, and my leftover is 3x plus 2. Okay, that is factoring 4-term polynomials. Look for those patterns, 3 and 1, 1 and 3, or 2 and 2, 2 and 2. All right, see you next time.